our channel. This is Science Lectures. Please consider subscribing and hit on the like button, comment in the comment section, and please watch the video till the end. So today we are continuing with transport, and today we want to have a look at facilitated diffusion. So we are going to see how facilitated diffusion is and what happens in facilitated diffusion and what falls under facilitated diffusion. So we need to start off, I think, with the definition. What is facilitated diffusion? So facilitated diffusion, it has something which makes it similar to simple diffusion, like we saw for simple diffusion. If you didn't see the video for simple diffusion, you please check out on the video. So they have something in common. But let's define simple facilitated diffusion. So facilitated diffusion is the transport of molecules from a region of high concentration to low concentration, from high to low concentration. Simple diffusion, high concentration to low concentration, with the aid of carriers or channel proteins. So this happens with the aid of carriers or channel proteins, and this is the distinction of facilitated with this one, simple diffusion. In simple diffusion, we saw that a molecule moves from high concentration to low concentration, but the transportation there isn't aided with carriers or channel proteins. And the transportation in simple diffusion, no ATP is involved. Also in facilitated diffusion, we don't require energy in form of ATP. So it is just transportation of these molecules. However, in facilitated diffusion, the transport molecules are saturated. So we reach a point where all the transport sites are occupied. In other words, the graph of facilitated transport, a sketch will appear like that. So if this is so that will be the sketch. If compared with simple diffusion, this will be the graph for simple diffusion, and this one will be the graph for facilitated diffusion. So transport increases as we increase the concentration. If this is the concentration, in fact, if this is the time, and this is the concentration, with time, the rate of transportation will increase, but it reaches a point where all the sites are occupied and it will level off. And that is the moment where we have saturation of the active sites. So this is a brief introduction to what facilitated diffusion is. But we need to give some examples of facilitated transport, like in the body where it happens. So one of the examples of facilitated diffusion we are going to give a channels. We will start with a ligand gated ion channel. So this one has a word ligand and gated. So that means we need a ligand, and a ligand attaches where? A ligand attaches to a specific receptor. So in this type of facilitated transport, we'll have a ligand attached to a specific receptor, and when it attaches to a specific receptor, this will cause opening of the channel, and we'll have influx of ions, the ions required. Let's say we have a receptor having a ligand. Then when the ligand attaches to the receptor, there is opening and influx of ions then happens. So that is what we refer to as a ligand-gated ion channel. So, for example, if we are having an ion, like sodium ion, being transported into this channel, that is what happens with the ligand. How a ligand must be present to attach to a specific receptor such that there is opening of the channel and influx of the ions will take place. Then which other example can we have? We can have a voltage gated ion channel. Voltage gated ion channel. And for a voltage gated ion channel, we need a voltage, a specific voltage to be reached, a specific voltage level to be reached, or a specific voltage value to be reached for this channel to open. Let's say, for example, you can give an example. Let's say if we have voltage of 50 millivolts and it causes opening of that channel. That's our voltage gated ion channel will work. We have voltage of at a specific level, let's say 50 millivolts, and it causes opening of that channel and influx of the ions takes place. So that is a ligand gated ion channel and a voltage gated ion channel. Ligand bases on a ligand attaching to a specific receptor opening the channel influx of ions. Voltage gated ion channel is where we reach a specific voltage, then opening of these channels and influx of the ions takes place. Of a channel under facilitated diffusion is the blood transporter. The blood transporter. And this blood transporter is used in transportation of glucose. But what we should not forget as we proceed with facilitated diffusion, all these molecules are being transported from where they are in a high concentration to where they are in a low concentration. So a ligand-gated ion channel, this sodium is moving from where it is in a high concentration to a low concentration. Voltage-gated ion channel, also if we have sodium in a voltage-gated ion channel or calcium, it will move from where it is in high concentration to low concentration. Even in the leaky, same applies to the leaky channel and the glucose transporter. So for the glucose transporter, we'll be transporting glucose from a region of high concentration to a region of low concentration. No ATP, no energy in form of ATP is consumed in facilitated diffusion. That is very important for us to note. Then we have a fifth example under the facilitated diffusion, and that is a mechanically gated ion channel. So we have what we refer to as a mechanically gated ion channel. So where is this channel applied in the body? Where is it? How is it relevant in the body? Let's imagine you're lifting a heavy weight. Let's imagine someone is lifting a heavy weight, and the weight suddenly drops and hits maybe the foot, maybe someone's foot, and the weight applies pressure onto someone's foot. It will open what we call the mechanically gated ion channels. And when these mechanically gated ion channels are open, let's say these are mechanically gated ion channels. Once these channels are open, they will lead to influx of sodium ions, of ions like sodium ions. So when we have sodium ions influxing, entering somewhere into the body, they will lead to transmission of an impulse. And this impulse will go to the pain receptors. So someone will be able to notice that they are in pain, they are having pain because of presence of the mechanically gated ion channels. So this is what is all about facilitated diffusion. I've said molecule moving from high concentration to low concentration. We don't use energy in form of ATP, but transportation is aided by either channels or carriers. And examples, we have a ligand-gated ion channel where we need a specific ligand touching to a receptor, causing opening of these ions, of the channels, influx of ions. Voltage-gated ion channels, we need to reach a specific voltage, a certain voltage for the channels to open. Leaky channels, those ones are always leaky, they are leaking. So we can have potassium ions entering, bringing about a resting membrane potential. Then the blood transporter, specifically for transportation of glucose from where it is high in concentration to where it is low in concentration. Then mechanically gated ion channels, the one that will apply for the pain receptors. So that is it for facilitated diffusion.